So let's fill this out together. So these are all things that we should know about these various types of bonding. So ionic, first of all, what types of elements are involved there? I mean metals, nonmetals, and so on. What would we put there? Yeah, that is a metal and a nonmetal in combination. How about covalent? What's that going to be? Nonmetals. Need something in between, I think, here. And then metallic, obviously, is just metals. So we're talking like so either a pure metal element or an alloy like iron, like copper, like zinc, or an alloy like brass or steel. There's no compounds. Alloys are not considered compounds. So just a piece of metal, anything that you would call metal, that's what's held together by metallic bonds. Questions about that? Another thing that we should know about all these is what the electrons are doing. Like, are they transferring? Are they sharing? Or what? So how about with ionic? What are those electrons doing there? Do they share, transfer? I think the test isn't today. Transfer. Which is the one that's losing the electron and which is the one that's taking it? The metals lose it. Remember, metals form cations. So it's going to be from metal to nonmetal. As far as covalent, this is where we are sharing electrons. And then metallic bond, typically how we refer to that is a sea of electrons. So we've got those delocalized electrons. Questions about that? Okay, physical state. By this, I mean like solid, liquid, gas. We've not talked about this in class. It shows up a little bit on that covalent thing, but ionic compounds are always solids. Whereas covalent compounds can actually be all three. You could have a covalently bonded gas, like carbon dioxide, for example, or methane that comes out of those gas jets. You could have a liquid. You could have a liquid like H2O, of course, yes, or various kinds of alcohol, or lots of different things like that. Or you could have a solid, like sugar, for example. So basically, be anything. It can be any solid, liquid, gas. What should I put for metal? What are those? Solid liquids or gases? Solids. Except mercury. Mercury is a liquid metal. It's that blue one up there. It's a liquid metal. Yeah, it's blue up there on the periodic table. Melting point. Very high. So, like, for example, if you go home today, and you get out a frying pan, and you put the frying pan on the burner, and you dump some sugar in the frying pan, and you turn it on, that sugar will melt, once the pan gets hot. If you leave it on there long enough, it'll like harden into like blackness and like ruin the pan, and your parents will be mad at you. So don't do that. In fact, probably don't do any of this, but I'm just telling you. You throw a little butter in there, that's basically how you make caramel. You do the same thing with salt, that ain't ever gonna melt. You can turn your burner as high as you want to. If you got a gas burner, stick it in the flames of the gas burner. It still is not gonna melt. So salt, of course, being ionic, has a much higher melting point than... Now, there is a couple of big exceptions. Diamond is like one of the big exceptions. That diamond is 100% carbon. I don't know if you knew that. Same thing like the graphite in your pencil is. Metals, for the most part, have high melting points, actually lower than most ionic substances. There's exceptions to all this and all that kind of thing, but for the most part, metals are going to have higher melting points. Obviously, mercury's is a pretty low because it's a liquid at room temperature. Structure, by what I mean by this, is that crystal lattice we were speaking about earlier. Where this is how should I put this? This with the metals are also form a lattice of sorts with that sea of electrons that we were kind of trying to draw earlier. Okay, so, last thing here. And I'm going to show you an example of this in just a moment. Ionic compounds do not conduct electricity as a solid. Now, if you take them, and again, I'll show you this in a moment, if you take them and you melt them, like you get them really, really, really hot, and you melt them, they will conduct electricity, or if you dissolve them, they will conduct electricity, but not as a solid. Most covalent compounds do not conduct electricity. What about metals? Do they conduct electricity? Yes. That's one of the nice things about metals is they conduct electricity pretty well. And I'll show you this conductivity thing here in action in just a second, but any questions come to mind about that for the moment? So this is definitely, again, if we are in person next time, this is definitely something that you want to look at and study, is be able to